Hello everyone, once again welcome in our class. So yesterday in the previous class we complete the second chapter of our syllabus, that is application of derivative. Now the next chapter is indefinite integral, right? So today we have see that. So actually integration is nothing but the antiderivative, that is opposite of derivative, is known as also known as a antiderivative, right? And are of two type. It is as indefinite integral and definite integral. There are two types of integrations: indefinite integral and definite integral. So both integrals are bifurcated in the both different chapters. So here we see the indefinite integral. So what is difference between these two integrals? We see in the next chapter, because first of all we learn about the definite integral, then we automatically know the difference between them, right? Okay, so see here indefinite integrals. What we have to study in this chapter? First we will see that is definition and properties, then different techniques to find the integration. That first one is by substitution method, then second one is integration by parts method, and third one is integration by partial fraction, right? So how we define as, see here this short definition is given. We will try to find a function whose derivative is known. Derivative known, if we say f of x is the function, then f dash x is the derivative of that function, and we find g of x such as g dash x equals to f of x. So here integration of f of x with respect to x is g of x, or g of x is the called a primitive of f of x. Integration is also known as a primitive, right? So g of x is nothing but the primitive or integral of the f of x, right? Or again, in very easy way, we say that if f of x, derivative of f of x is g of x, then integration of g of x is f of x, that is reciprocal. If we take some example, say we know that the derivative of sin x is cos x, right? See the example. We know that the derivative of x cube is 3x square, right? Therefore integral of 3x square is what? With respect to x is x cube, right? And this is shown with the sign of integration, namely this is actually the sign of integration, and we write it as integration of 3x square is x cube, right? Okay, then see the next one. See, integration of f of x is g of x. It is read as a integral of f of x with respect to x is g of x. Since derivative of constant function is 0, so integration of f of x dx equals to g of x plus c, where c is the arbitrary constant, right? Therefore in indefinite integral the constant of integration c is used, right? Now see some elementary integration formulas, right? So what is, we know that the derivative of x to the power n is what? X to the power n plus 1. Now integration of x to the power n is what? X to the power n plus 1 upon n plus 1. Okay, so how it is fine? See, derivative of x to the power n plus 1 upon n plus 1, if we consider, so it is n plus 1 is constant, and derivative of x to the power n plus 1 is n plus 1 into x to the power n plus 1 minus 1. 1 minus 1 cancel, so x to the power n is remaining. If we cancel out n plus 1 n plus 1, here only x to the power n. That means derivative of x to the power n plus 1 upon n plus 1 is what? X to the power n, right? Therefore integration of x to the power n is what? X to the power n plus 1 upon n plus 1, right? So it is applicable for this also. When we use in terms of the standard form, we know the important result of integration of f of ax plus b. What is the result? That is ax plus b to the power n plus 1 upon n plus 1, right? So if we used this one, ax plus b to the power n, then it is ax plus b to the power n plus 1 upon n plus 1 into a plus c, right? So this is the important result actually that we see in the 11th class also. Now these are the standard formulas of derivative and the reciprocal of that, that means the integration. See, derivative of a to the power x upon log a equals to a to the power x, therefore integration of a to the power x dx equals to a to the power x upon log a. How it is find? See, we know that the derivative of a to the power x is a to the power x into log a, right? But here log a, here in multiplication goes to here means in denominator. So here therefore a to the power x, integration of a to the power x is a to the power x upon log a, right? And using important result, this is like this, right? Similarly for integration of e to the power x is e to the power x, and using important result it is like this. Then derivative of sin x cos x, so integration of cos x is sin x plus c. Using important result, it is like this. Derivative of cos x minus sin x, therefore integration of sin x is minus cos x. By using important result, it is like this. Derivative of tan x sec square x, integration of sec square x, therefore it is tan x. Using important result, it is like this. So all the formulas are written in your textbook. So see and note down in your notebook. See the next one, integration of sec x equals to sec x into tan x. So therefore, sorry, derivative of sec x equals to sec x into tan x. Therefore, integration of sec x into tan x equals to sec x plus c. And using important result, this is like this. Similarly, for it is cosec x, cot x, and log x, and so on. Right? So see the formulas and note down and memorized. All the formulas you have to memorize. The formulas of derivative and formulas of integration also you have to memorize all the formulas, because in examples we have to know each and every formula, because without formulas we can't do anything in here, right? Now see the next one, that is the first theorem, that the if f and g are the real value integrable functions of x, then integration of f of x plus g of x dx equals to integration of f of x plus integration of g of x. That is separate the integration, simple one. We say it is the separation of the integration. Integration of f of x plus g of x is integration of f of x plus integration of g of x. Separation, right? It is exists for negative symbol also. That is I think the second theorem in the textbook. What is that? Integration of f of x minus g of x dx equals to integration of f of x dx minus integration of g of x dx. So that also exists. That should be the second one. I think that is in the your textbook, right? So how we prove this? See here. Let integration of f of x is g1x plus c, and integration of g of x is g2x plus c2, where c1 and c2 are the constants, right? So according to definition, if integration of this equals to right side, then derivative of right side equals to left side, right? So derivative of this g1x plus c1 equals to f of x, okay, and derivative of g2x plus c2 equals to g of x, okay. Then therefore in derivative of g1x plus c1 plus g2x plus c2, if we add these two, what do we get? Derivative of, again separate here, derivative according to the separation rule of the derivative of sum. So derivative of first plus derivative of second term, right? And the first term is nothing but f of x plus second term is what? G of x, right? By definition again, if we see derivative of this one, derivative of this one is f of x plus g of x, therefore integration of f of x plus g of x equals to what? This one, g1x plus c1 plus g2x plus c2, and g1x plus c1 is what? G1x plus c1 is what? G1x plus c1 is integration of f of x, and g2x plus c2 is what? Integration of g of x. So that is the final result. This should be the result and the proof of the first theorem. Integration of f of x plus g of x equals to integration of f of x plus integration of g of x dx, right? So this is the proof of the theorem. And if we see the second one, that is I think for negative symbol, so it can be proved very easily in the same way. So you try to solve that one. Okay, and what is next? Okay, again it's the same theorem of the integration of k into f of x dx equals to k into integration of f of x. That means if the constant is along with the function and that is inside the integration, then constant is take outside the integration and the integration of the function can be calculated by using the formulas. Right now that proof also is given in the textbook to try to memorize and try to understand that. If any problem you face, then contact me. Okay, then see the example. Very easy examples are there in the first some exercises, then very complicated examples also here. Okay, so see first one, evaluate the following function: integration x cube plus 3 to the power x dx. Right here if we see, we seen that there is a summation and inside the sum there are the two terms or function. You say first one is x cube, second is 3 to the power x, right? So first theorem, according to the first theorem, the integral is separated. So integration of x cube dx plus integration of 3 to the power x dx, integration is separated. Now we formulate this by using the standard formula of integration of x to the power n. Here x to the power constant, right? So what is the derivative integration of x to the power n? That is x to the power n plus 1 upon n plus 1. So here n equals to 3, so x to the power 3 plus 1 upon 3 plus 1, that is x to the power 4 upon 4, right? And the standard formula of integration of a to the power x is what? A to the power x upon log a. Here a equals to 3, so it 3 to the power x upon log 3 plus c. This should be the answer for the first example, right? See the second one, again integration of, evaluate integration of sin x plus 1 by x plus 1 by cube root of x dx. Right, again if we see here the sum of the three functions, first one is sin x, 1 by x and 1 by cube root of x. So separate the integration first of all in this way, right? Then find the integration by using the standard formula of integration of sin x is minus cos x, integration of 1 by x is log x, and integration of 1 upon cube root of x is what? That is by using the formula of x to the power n. How x to the power n? Because its cube root means to the power 1 by 3, and 1 upon x to the power 1 by 3 means x to the power minus 1 by 3. That means n equals to minus 1 by 3, and use the formula of x to the power n. What do we get? X to the power n plus 1 upon n plus 1. N is minus 1 by 3. So x to the power minus 1 by 3 plus 1 upon minus 1 by 3 plus 1 plus c. Where c is the constant of integration. Okay. See what is the final answer then? Minus cos x plus log x plus x to the power minus 1 by 3 plus 1 is 2 by 3. And divide by also 2 by 3 plus c. So what would we get? Minus cos x plus log x plus 1 upon 2 by 3 means 3 by 2 into x to the power 2 by 3 plus c. This should be the final answer in this case, right? What is the next one? C. Integration of tan x plus cot x whole square, right? So how we find it? We are given the square term f of x plus g of x whole square. So first of all we have to simplify this one. We have to simplify this square by using formula a plus b whole square. We know that a plus b whole square is a square plus twice ab plus b square. So here a is tan x, so tan square x plus twice tan into cot plus cot square x, right? Then simplify first of all again. Tan square equals to tan square x plus 2 into tan x into cot x. What is tan into cot? Tan and cot are the both are the reciprocal of each other, because tan x equals to sin x upon cos x and cot x equals to cos x upon sin x. So both are the reciprocals, so cancel out the terms and we got only one, right? So this should be cancelled, and plus cot square x, right? Then use the result, because we do not have standard formula for integration of tan square. Therefore if we separate integration in this step, we do not solve the final answer. Okay, so therefore we have to simplify by using the trigonometric formulas, by using identity. So tan square converted to sec square x minus 1 and plus 2, and cot square x converted to cosec square x minus 1, right? Then minus 1 minus 1 minus 2 plus 2 0, remaining is sec square x plus cosec square x. And in this step we separate the integration. So integration of sec square x dx is 10x, and integration of cosec square x dx is minus cot x plus c is the constant of integration, right? So in this way we have to solve the examples. Lot more examples are there. Try to solve the examples of exercise, or the understand the solved examples, or we take some examples tomorrow, right? This is enough for the today. Try to understand and try to memorize all the formulas, because without formulas we can't do anything. Therefore we take the short lecture on that today, because you have to memorize all the formulas of derivative and integration also, right? So try to memorize that, and we will be continue tomorrow.